Hello, here's a video about turning fractions into percentages and decimals. There are a few things that you need to understand in order to be able to do this. You need to understand, firstly, that percent is the Latin for out of 100, so any percentage can be written straight away as a fraction over 100, easy peasy. You need to understand, secondly, that percentages and decimals are easily converted from one to the other. To turn a percentage into decimal, you can divide it by 100, and to turn a decimal into a percentage, you can multiply it by 100. And the last thing you'll need to be confident with in order to follow this video is the bus stop division method. It's what we call the bus stop method. You'll see it later on. It's the written method of division that we tend to use in England, and I suspect most other places. Let's start on it. First of all, some fractions are easily converted into percentages and into decimals because you see in purple here we have a number of fractions with different denominators. We have 7 tenths, 17 over 50, 3 over 2, 21 over 25, 3 over 4, 11 twentieths and 9 fifths. And what you should notice about all those denominators, the number on the bottom, all the denominators are factors of 100. Factors of 100, which means we can easily turn them into 100 through a simple multiplication. What do you do to 10 to make 100? You times it by 10. What you do to the bottom of a fraction, you do to the top to find an equivalent fraction. So we do 7 times 10 and we get 70. What do you do to 50 to make 100? You times it by 2, so we double 17 to get our fraction over 100. What do you do to 2 to make 50? So to make 100, you times it by 50. So we do the same thing to 3 to get 150. Notice it's a top-heavy fraction, so we get a fraction greater than 100 over 100. And what do you do to 25 to make 100? You times it by 4. 21 times 4 is 84. What do you do to 4 to make 100? You times it by 25, so we do 3 times 25, which is 75. What do you do to 20 to make 100? We times it by 5, so 11 5 is 55. 5 times 20 is 100, and 9 times 20 will be, come on brain, 180, it's a bit early, sorry. 180, another top-heavy fraction there. Once you've got a fraction over 100, of course, you have a percentage, because like we said earlier, percent means out of 100. So 7 tenths is 70%, 17 fifties is 34%, 3 halves is 150%. Yes, it's possible, and so on. In green, we have some numbers which should be relatively easy to convert also, not because they're factors of 100, 200, 500 and 1200 as examples, but because they're multiples of 100, and therefore they should easily be converted into 100 by some form of division. 200 divided by 2 is 100. What's 83 divided by 2? That's right, 41.5 or 41.5. Yes, you can write the fraction in that way for the purposes of making it into a percentage or to understanding what it is as a percentage. It would be 41.5%. 500 divided by what makes 100? Of course, divided by 5. How many 5s make 75? 15 5s make 75. Take your time and work it out. I'm much better at maths than you are. This is an easy one, isn't it? Because you might just look at 600 over 1200 and recognise straight away that it's a half. But just to go through the process, 1200 divided by 12 will give us 100. So we do 600 divided by 12. And since 60 divided by 12 is 5, 600 divided by 12 will be 50. And 50 hundredths is, of course, 1/2. Moving on. Other fractions can be more challenging. Here are a couple of fractions with slightly more challenging denominators. They're more challenging because they're not so easy to convert into a fraction over 100, which is what we really want in order to find our percentage. 40, unless you multiply it by a fraction, does not convert straight away into 100. But one way you can approach a question like this is to take it in more than one step. Because what you can do to 40 is divide it by 10 to make 10. And once you're on 10, of course, you can then times by 10 to make 100. 12 divided by 4 in the first step is 3, and then 3 times 10 is 30. So it turns out 12 over 40 is the same as 30, do it properly, over 100. Similarly with 120, not quite so easy. A few ways you could go, but again, I might be tempted to convert it to tenths, because 120 divided by 12 is 10, isn't it? Do 96 divided by 12, that's 8, isn't it? And then times by 10 again, and we get 80. I'll just rub that last one out and show you actually that there's often alternative ways of going on this. There are different jumps you can make, and very often more than one way will work. For example, if we understand that 20 is also a factor of 100, I can divide 120 by 6 to make 20. And I can divide 96 by 6, that gets me, what, 16? And then from 20 to 100 again is an easy jump. You times it by 5 and you do 16 times 5, and funnily enough you still get 80, so it's still 80%. as it should be. And there are other ways we could go there as well, but I won't do any more. That just gives you a general idea. So just to recap the first two pages, some fractions are very easily converted, namely the ones where the denominators are factors or multiples of 100. That's very straightforward. Sometimes you can do it the same way, but by taking more than one jump you can make your life easier. Other fractions are even more hard or difficult or challenging. That's the fractions such as 3/7, where the denominator really is not at all amenable to the method we've just looked at. And this is where we get onto that bus stop method that I talked about just at the start of the video. Because one way you can convert fractions to decimals, and this works for any fraction, easy, medium or hard, is to treat your fraction as a division problem and to divide 3 by 7, divide the numerator by the denominator. You should be understanding now in maths that all fractions can be considered as division problems, and all division problems can be considered as fractions. So if we do 3 divided by 7, the 3 obviously goes in the bus stop, that's how we're dividing it by 7, and we do our bus stop, and a nice long one, you'll figure out why in a second if you haven't already. We say to ourselves, how many 7s go into 3? And the answer, of course, is none. And we haven't used the 3 at all. The other thing you need to understand, which I didn't mention at the beginning, is that all whole numbers can be thought of as being that whole number, point, an infinite number of zeros. So 3 is actually not just 3, it's 3.000, and we could go on, and maybe we will in a minute, 0, 0. And we can use those zeros for the remainders that we generate when our whole number doesn't divide exactly. So here, 3 divided by 7 goes 0. We haven't used the 3 at all, so we carry it across to the first 0 in the decimals column. Don't forget your decimal points. And we make 30. And then we say 30 divided by 7, and that does go 4 times remainder 2. I'm going to go quite quickly here. Don't worry if you can't keep up. You can do it in your own time when you've got time. 20 divided by 7 is 2 remainder 6. 60 divided by 7 is 8 remainder 4, so another 0. 40 divided by 7 is 5 remainder, come on brain, 5. 50 divided by 7 is 7 remainder 1. 10 divided by 7 is 1 remainder 3. And now I get something, I notice something. 30 divided by 7 is 4 remainder 2, and I don't need to go any further because, look, here I had 30 divided by 7 and got 4 remainder 2, and I'm just about to do it again. I'm going to actually get the same answers from now on, aren't I? Because I'm just done 30 divided by 7 is 4. I would put a 2 in front of the next 0 to get 20, and I would get a 2 remainder 6, and then I get 8 remainder 4. And what we've realised is that this answer actually recurs. It's a recurring decimal answer. So the answer to 3 divided by 7 is 0.42857114 recurring, meaning all those digits would, after that last 1 rather, would recur. They keep going on forever. That block from 4 to 1 will just keep going on and on and on and on forever. So we don't need to carry on working it out. We realise that's what's going to happen. So we show recurringness with a dot above the first digit in the sequence that recurs, and a dot above the last digit in the sequence that recurs, no matter how many digits there are in that sequence, and that indicates to the reader that it's a recurring sequence with that many digits in it. That's our decimal answer, and to turn a decimal into percentage we can times it by 100, like I said at the beginning. So if we times 0.42 etc. times 100, we move the decimal point 2 spaces to the right, and we get 42.857142 recurring. There it is. Which we could, if we wanted to round it, let's be clever, let's round it to 2 decimal places, let's say. We get 42.8, 5 followed by a 7 to round up, 6%. Or if we round it to the nearest whole number percentage, it would be 43%, wouldn't it? So what you do with your answer, whether you round it and how you round it, will be up to you or up to anybody who's asking you a question about it. But that's how we can turn any fraction into a decimal and percentage, is by treating it as a division problem. Let's do another one. 2 over 13, that means 2 divided by 13. 2 divided by 13. Does 13 go into 2? Of course it doesn't. So we'll put our decimal point and a 0 there. We haven't used the 2 at all, so we carry it across. 20 divided by 13 is 1 remainder 7. How many 13s go into 70? Come on, brain, it's really not working today for me. 52, 68, I reckon, is in the 13 times table. That's, am I right about that? No, I'm wrong. 5 10 to 50. No, I'm wrong. 5 10 to 50 and 3 5 to 15, but 5 remainder 5. There we go. 3 13 to 39, so that'll be 3 remainder 11. 110 divided by 13, there's a fun one. 130 is 10 13s, take away 26 would be 104, so that's 8 remainder 6. 60 divided by 3 will be 4. 3952 remainder 8. 80 divided by 13, I think it's going to be the last one, I think it is. 80 divided by 13 is, come on brain, 65, 75, 78. So that's 6, remainder 2. And look, I've got a remainder 2 again, which means we're going to start the sequence again. Let's rub that out so the arrow's not there anymore. There we go. So when I get my 80 divided by 13 is 6, remainder 2, I would put a 2 in front of the next 0, but then that means I would just start this sequence again. So the answer to 2 divided by 13 is 0.153846, recurring again. Lots of fractions recur as decimals, you'll find. Up till now at school, you've probably been given fairly straightforward ones, but there are lots and lots of them that end up recurring like this, and like the previous one. Times that by 100 to make it a percentage. Decimal point 2 spaces to the right. What do we get? That's right. 15.38461 recurring percent. So the nearest whole number, 15%. For one decimal place, how about that? 15.4%, and so on. There's a method, that division method that we've just shown you in one of those last two examples, here and here, always works. It will always convert a fraction into a decimal for you. It might, as in these two examples, be quite long-winded and convoluted. You may get a recurring answer, but it works for any fraction. Here are two much more straightforward ones, similar to the ones we looked at earlier. I'll just show you that it works here as well. 3/5 is 3 divided by 5. You should already be thinking that 3/5 is 60% because it's 6/10 and 60/100. But let's just do it this way. 3 divided by 5, 0 remainder 3. Put the 3 in there. 30 divided by 5 is 6. And boom, there we go, 0.6. And 0.6 times by 100 is 60%, that's right. And 11 divided by 8, top heavy, isn't it? 11 divided by 8. So 8 goes into 11 once, remainder of 3, so we'll put a decimal point and a 0. Carry the 3 across. 30 divided by 8 is, don't get a decimal point, 3 remainder 6. 60 divided by 8 is 7, remainder 4. And 40 divided by 8 is 5. So we get 1.375. Times that by 100, and that's not recurring, by the way, isn't that nice? 1.375 times 100 is 137.5%. So in summary then, fractions can be converted to decimals and percentages as always. Sometimes it's easily done if the denominator is a multiple or a factor of 100, in the way we looked at here. Sometimes you can do it that way, but by going a couple of steps. And other times with fractions with much trickier denominators, just do a division method to turn the fraction into a decimal, and multiply the decimal by 100 to give yourself a percentage. There and there, sometimes they recur, and here they didn't recur, but our method still works. That is a video on how to turn fractions into decimals and percentages. Hope that's helpful.